Good day, students. It's Shifula Dama here. I'm here to present a topic on geometry. Most of the students just felt it's not coming out clearly in other presentations, in the past presentations, and I will present most of the topic or of the unit or of the chapter on geometry. You can see my contact details as always, and this is numeracy and mathematics. If we talk of geometry, for your studies is plane geometry. What do we mean by plane geometry? Plane geometry is about flat or plane shapes or figures. Some people call them shapes, some call them figures, like triangle, circle, rectangle, square, kite, trapezium, etc., etc. We have a lot of them. Some are five-sided figures, have got 5 sides, which are called octagon or heptagon, hexagon, nonagon, and decagon. When they are 10-sided figures, because they are plane, they are flat shapes, and they are part of plane geometry. Now, when we have these figures or shapes, some of them you are given and they look the same, and we call them in mathematics similar shapes or similar figures. And how do we know that they are similar? There are two characteristics. They are similar, number one, if their corresponding angles are equal. You will see on the diagram that will come on the next slide, their corresponding angles should be equal. And then, if I can draw quickly, roughly, if I can draw two diagrams that looks similar, when we say corresponding angles should be equal, this angle up here should be equal to this angle up there. The angle on the right should be equal to the angle on the right on the small diagram. And the angle on the left should also be equal to the angle on our left-hand side. Yes, one diagram is big, another one is small, but they are similar diagrams. They are called similar diagrams. Next, the second characteristics that we look at to determine if angles are similar or diagrams are similar, figures are similar, these shapes, if they are similar, the second characteristics that we look at is that their corresponding sides are in the same proportion. What do we mean? If this side is 2 centimeters, this one will be 4 centimeters. If this one is 5 centimeters, then this will be 10 centimeters. How will we know that they are in proportion? These ones, 2 and 4, if you simplify them, 2 goes into 2, 1, 2 goes into 4, 2 times, you will get 1 over 2. If we try to simplify 5 and 10, we write it as 5 over 10. When we are simplifying them, we say 5 goes into itself 1 time, and then 5 goes into 10 2 times. If you look, it's the same proportion. You will get the same answer if you simplify these two fractions or two numbers of corresponding sides. Which means when we say the sides have to be in proportion, they have to simplify to the same answer. Okay, then we continue. Similar figures have exactly same shape. That's very important. Their shape should be the same. If it's a triangle, it should be a triangle. If they are squares, both of them, the two shapes should be square. If they are rectangles, they both have to be rectangle. Examples of similar figures. As I said, on the next slide you will see, and this is exactly what I explained. The corresponding sides, corresponding angles should be equal first, and their corresponding sides should be in the same proportion. We continue. Under geometry, we also have 2D shapes. 2D, D stands for dimensions. 2 dimensional shape. Dimension. Two-dimensional shapes. Why are they called two-dimensional shapes with two dimensions? Because if you look at them, I'm just giving you one of them, a rectangle. Some look at it and think it's a square. On this diagram, you can see its flat shape, and you can also see the edges, which means you can only see two places, the flat, and then you can see the edges. So you can only see two things on that diagram. That's why they are called two-dimensional shapes. And I just gave you all of them there. There's a square, a rectangle, a triangle, a parallelogram, a trapezium, a circle, a kite is also part of two-dimensional shapes, pentagon, five-sided figure, hexagon, heptagon, octagon, and so on and so on. You can also see one figure with 10 sides. Those are all called, the flat shapes now are all called two-dimensional shapes. In geometry, out of these two-dimensional shapes, you can see there are some figures with four sides. For example, the first one, the square, the rectangle, the parallelogram, the trapezium, the kite. Those ones have four sides. And when figures have got four sides, in mathematics we call them quadrilateral. Quadrilateral, which means quad from other languages, because English is also borrowed from other languages. Quad means four. Lateral means, and I think it's explained in your book as well, means sides. So those quadrilaterals have got four sides. And if you look at them in that diagram, and they are colored beautifully, you look at a parallelogram. I gave you the type of a quadrilateral, a figure, and I also give you the properties. What makes it to be called a parallelogram? I give you a rhombus, and I give you the properties of a rhombus. What makes it different? Yes, they are all having four sides, but what makes them different from each other? In a rectangle, you can read its properties there. Square, kite, trapezium in your book, and trapezoid in some other mathematics book. You can read their properties and to understand and make a difference between these quadrilaterals. Why are they called quadrilaterals again? Because they all have four sides. Okay, we continue. Apart from two-sided figures, those figures that we just finished explaining, we also have got three-dimensional shapes. It's becoming interesting. Three-dimensional shapes. Why? Because we can see three sides. If I can quickly draw a rough one, maybe I can draw a cube. You can see, as a mathematics teacher, future mathematics teacher, you should know how to draw these figures. And you just connect the points, you connect them to make your box, you connect the points. That one looks like a box, even though it's not a perfect one like the one in your diagram. So if you look at the box, you will see the top part, yes, or the other side. We can see the left-hand side, and we can also see the one in front. You can only see three sides. We can see three sides. That's why it's called 3D shapes. We can see three dimensions. So I gave you the examples of, the first one is a cube, the second one is a cuboid, the third one you can see on top there is a cylinder, then there's a triangular base pyramid or prism, triangular base prism, and then we've got the rectangular base pyramid, and then you have got that one of 6 sides, and then we've got a sphere. All those are three-sided figure or three-dimensional shapes. Yes, we continue. These three-dimensional shapes, we can have their nets. What is a net of a diagram? it means when you open that box. When you open it up, for example, the one that I just drew, if you open it up, you will see, am I having an example on these slides? Yes. You will see it will look something like this. Like this, and then another one here to close off. Then you will see that one will look, when you close it up, it will look like a cube. Those are the nets. The net is when you open up this figure. Now I gave you the example. First we say a shape which can be opened up, as I said, and folded, and you fold it again to make outside surface of a three-dimensional shape is called a net. When you open it up, that shape is now called the net of a three-dimensional shape or of a solid shape. Because you can open it up and you can also close it again. So when you open it up, it's called a net of a cube, a net of a cuboid, a net of a hexagonal. That is now a six-sided figure, a net of a cylinder, a net of a tetrahedron, a net, and other nets also on the left-hand side of when you look, and so on and so on. What are we expected to know? You should know how to draw them. If I say draw a net of a cuboid, you know how it looks like. Draw a net of a cylinder, you know how it looks like, and so on and so on. We continue. Under geometry, we also have got a topic on transformation. What is transformation? Transformation is the movement. It's a movement that changes the position of a shape and or the size of an object. We've got four types of transformation. Number one, we've got enlargement. Number two, we've got rotation. And then number three, we've got reflection. And number four, we've got translation. Those are the four types of transformation. What does it mean when you move the movement of the shape? Remember, we have got two-dimensional shapes. We usually move the two-dimensional shape, the flat shape. Enlargement, if we look at it, it's in the name. The diagram is enlarged. It's made large. There's a small one and you enlarge it, you make it large, and that transformation is called enlargement. Rotation, again, the name says everything. You rotate it. The diagram, when you rotate it, probably I should also demonstrate. First, you are given a small diagram for enlargement. This is an enlargement of A. If this is A, this will be A hash, because this is an enlargement. They are not the same. They are all triangles, but one is small, one is an enlargement of the other. Okay, we'll go in detail looking at the example. Rotation. If we are having, let me just give you the example of a triangle again. But now with rotation, we should only rotate, we rotate it either 90 degrees or 180 degrees, mostly at your level, or 270 degrees, or a full rotation. When you rotate this diagram, you rotate it like this, it's 90 degrees. You rotate it and it's facing down, is 180 degrees. When it's facing this side, you rotate it, it's 270 degrees, and you rotate it back to its original, how it was looking first, how it was standing. That is now 360, full revolution. Full turn is 360 degrees. What now if we turn it for 90 degrees? It will look something like this. You turn it 90 degrees, it will stand like this, and is it 90 degrees? It will now stand. Let me just start all over again. Redraw, because we have to see how it will stand. Then it will look like this. You have turned the diagram for 90 degrees. It will look like that. This is now our 90-degree diagram. What if we turn it again? Then for 180 degrees, it will look something like this. It will now, how will it look like? But you will see if you turn it, it was like this. Now it will look like this. This is now 180 degrees. What if we turn, this is now 180 degrees. What if we turn it 270 degrees? It will look 270, it will face up now to look like this. Then we say this is now 270 degrees. When you turn it back again, back to its original. But when you are having, you can cut out the diagram and turn it 90 degree, turn it 180 degree, and turn it 270 degrees. And then when you turn it back, it will be 360 degrees, a full turn. Now, most of the time in the examination, we will ask you to enlarge or to explain, mostly to explain the transformation. We won't tell you this is enlargement. Sometimes we tell you. For enlargement, if we say explain the transformation that is in the diagram, for enlargement you should only give the scale factor, because if it's big, there must be for enlargement. If this was 2, probably now it will be 8 units, because transformation is done in our Cartesian plane, the x-axis and the y-axis. So you will just count the units on our lines, and you will know this is 8 units, and this one, this side, you will know is 2 units or 3 units or 4 units, roughly. Okay, we continue. So when you are explaining enlargement, you give the scale factor and you give the center of enlargement. What about rotation? Rotation, you give a center of rotation and the direction. What do we mean? Remember, I show you how to rotate. Center of rotation, because sometimes it doesn't move. It's just at one center, and it's just the diagram that is moved, and it's explained very well in your study guide, and I will give you the page where you will find these explanations. And you, with rotation, center of rotation and the direction, we always rotate clockwise, the way the clock moves, or anti-clockwise. Or they will say rotate it anti-clockwise, the way the diagram or the clock doesn't go clockwise, the way the clock moves, or anti-clockwise, the other way around, the way the clock doesn't move. So with rotation, the center of rotation and the direction. Reflection is what you see in the mirror. Okay, probably we will need to demonstrate reflection. Reflection, we say transformation always happen in the Cartesian plane, whereby we've got x-axis and the y-axis, and some 1, 2, 3, 4, and you should know where are the positive numbers and where are the negative numbers. Equal spaces between the numbers. And then this side, 1, 2, 3, 4, 5, it goes on and on. It doesn't stop our Cartesian plane. That's why we indicate it with arrow. And on this side, we have got numbers again. Now with reflection, you will find you are given any diagram. You can be given any diagram there. Reflect it in the x-axis. You will be told to reflect it in the x-axis. It doesn't change the size. The size will still be the same. Equal diagram, and you reflect it in the x-axis. If you have to reflect it in there, let me make my original a bit darker. If you have to reflect it in the y-axis, in this line which we call y-axis, this line we call it y-axis, this one is an x-axis. Here we reflect it. We see the mirror here in between, and we reflect it in this line. If we say reflect it in the y-axis, it's like that, and it will look like this. like this, and it will face this side. Because you just reflect, if you fold your paper in the middle, this one will reflect exactly on this one in the y-axis. This one will reflect exactly on this one in the x-axis. But remember, when you are the one who's asked to draw it, the spaces, this space between the lines should be the same. One shouldn't be closer to the line or the other one should. The space between the diagram on both sides should be the same. That's very important. Then we come to translation. Translation is the movement of this diagram. If it moves from here, they say move it 2 times. 1, 2, counting of course on these blocks on the Cartesian plane. You move it 1, 2 on the x-axis, and you move it 1, 2, 3 on the y-axis. When you go up or down, you are moving in the y direction. When you are moving left to right, you are moving in the x-axis. So the movement is called vectors. For translation, we deal with vectors. You have moved it 2 in the x-axis, x should be up, and 3 times up. You move it 1, 2 in the x-axis, and you move it 1, 2, 3 in the y-axis. It depends if this one is negative or positive. Remember, these are positive numbers. If you look in your book, these are positive numbers. These are negative numbers. These are negative numbers. If they say move it -2 in the x-axis because x is up, then you move it going in the negative because all these ones are negative numbers. Negative numbers when you go down, -1, 2, 3, 4, 5, -1, 2, 3, 4, 5. All these ones are positive. 1, 2, 3, 4, 5, 6, and so on. 1, 2, 3, 4, and 5. So when you go to the right, positive numbers. When you go up, positive numbers. When you come down, negative numbers. When you go to your left hand, negative numbers. It depends on what you are given here. Is it a negative number? Then you move in the negative direction. If it's x-axis. If it's y-axis, which is negative, then you move down because the movement of the negative goes down. It's well explained in your book. So most of the time they will say, give the vectors how that diagram or figure was translated, was moved, or they move it and they say you should give the vectors. Okay, now we understand. But with transformation, I gave you the example of enlargement, yes. And I say you can now describe fully the transformation of the following diagram. And I told you with enlargement, you give the scale factor and the center of enlargement. Let's look at this one. How will we get the scale factor? Okay. When we look at that diagram, please look at the small one, because they started with a small one and enlarge it to the darker one, to the big one. They are all called ABC or CBA. Triangle CBA, or you can say triangle ABC. Now, how can I get the scale factor of enlargement? I look at only one side. It's better to look at line CB. Look at line CB on the first diagram. How many blocks does it cover? It covers on the small. We are having a small figure, and we are also having a big figure, the one that was enlarged. Very good. Let's look at CB, line CB. We want to find the scale factor. Let me just call it SF, the scale factor of enlargement. The scale factor of enlargement on the small diagram, CB, line CB, is 2 units. And on the big diagram, you're looking at line CB on the big diagram, small and big diagram. On the big diagram, 1, 2, 3, 4. We are having 4 units. What is the scale factor of enlargement? Scale factor of enlargement, we say the big diagram divided by small diagram, the scale factor is 2. What are we saying? We look for scale factor. To get the scale factor, you look only at one side. Because at the end of the day, all the sides will give you the same answer. The side that is easier for me to work out is side CB. Remember, the side CB on the slides or the triangle have got 3 sides. But let's look at side CB on the small diagram, and we look at side CB or BC, let's just call it CB like we did with the other one. On the big rectangle, that will say on the CB on the small one is 2 units. When I count them, it's 1, 2 units. On the big diagram, CB is 4 units. You can count them and you confirm what I'm saying. Now, how do we find the scale factor? We say the units of the big diagram divided by the units on the small diagram. Then you work it out. 4 divided by 2, the answer is 2. Our scale factor is 2. But now in the exam, I want to see how you get it. I want to see your answer in order for you to score 2 marks. Very good. Now, that one. Okay, how do we find the center of enlargement? Because they ask us, and remember, if you go back to the slides, I said with enlargement, you should always give the scale factor of enlargement by how many units was the diagram enlarged. That's what it means. And you should also give the center of enlargement. How will we get the center of enlargement? You just join all the same points. C, you join it to C. I need to demonstrate because I won't be able to point in your slides, but you can see it on the presentation. For example, I won't draw like, let me draw like the one in there. It looks something like this. This is our small one, yes. And then the big one looks something like this. Yes, they are like that. For you to get the center of enlargement, you just join this point to this point. You draw a longer line coming this way now. It's just that mine are not drawn perfectly. Then you take this one and this one, because they correspond the same points, you join them. And then you take this one and then this one, you draw a line, you draw a line, you draw a line. When you draw those 3 lines, you will see where those 3 lines will meet somewhere here. And you are lucky on this diagram, that point is P. They will all meet where point P is. Now, what is the center of enlargement? You look at where point P is. Of course, I want to see the lines that connect them. When you see where point P is on your slide or in your presentation, you are not saying the center of enlargement is P. The center of enlargement, you read on the x-axis and on the y-axis. Remember, I said our transformation is always in the Cartesian plane, where you see the x-axis and the y-axis. So, when I look in that presentation, I want to read off point P on the x-axis. It's pointing at number 2. This is a Cartesian plane, yes, which is y-axis and x-axis. That point, it's coming straight to 2, and on the y-axis, it's pointing at 1. So our center of enlargement, 2, 2, 1, in brackets. You will see, you have got a lot of examples in your study guide. Just look at them, find the examples and solve them where? In your study guide on page 82. Then you will understand what we have just discussed here. Let's continue. In geometry, we also have got polygons. What is polygons? They are also flat shapes. Here we are talking about flat shapes with many, many sides. Okay, the word poly means many, gons means angles. Okay, using this definition of polygon, we see that the circle is not a polygon. If we draw a circle doesn't have any side. You can't say a circle have got many, many sides. No, the circle is not a polygon. Polygons are named according to the number of sides. Some of them we have already mentioned them, but we come closer now. We zoom in to see what are the polygons, those ones with many sides. And they also have got many angles. That's why they are called polygons. A polygon has the same number of sides as it has the angles. The number of sides is equals to the number of angles. I want to give you an example of a polygon. The diagram with 5 sides. I want to draw a diagram with 5 sides. 5 equal sides. Let's imagine those are 5 equal sides. How many angles? How many sides first? 1, 2, 3, 4, 5 sides. That diagram have got what? 5 sides. And our sentence say, if it have got 5 sides, it should also have got 5 angles. Angles are these spaces inside. How many angles? 1, 2, 3, 4, 5 angles. 5 sides and 5 angles. If I draw a diagram with 6 sides, it will also have 6 angles. And you have got examples of them in your books. Okay, a polygon that's why we are saying a polygon has the same number of sides as it has the same number of angles. Now with them we have got regular polygons. Also, that means all sides are equal, have the same length, and they have the same angles also of the same size. Irregular polygons, if a polygon is not regular, which means their sides are not equal, their angles are not equal, they differ, it's called an irregular polygons. Now we have got those polygons. I gave you the number in that table. I gave you the number of sides and I gave you their name. When the polygon have 3 sides, it's called a triangle. We learned these things since grade 1. If it's having 4 sides, it's called a quadrilateral. If it's having 5 sides, it's called a pentagon. 6 sides is called a hexagon. 7 sides is called a heptagon. 8 sides is called an octagon. 9 sides is called a nonagon. 10 sides, which is not here, is called a decagon. Okay, now we know if it's having that number of sides and equal number of angles and their names. You need to know them. In geometry, you can be asked to calculate the area of the flat shapes. Remember, we are doing plane geometry, and plane geometry is all about flat shapes mostly. Calculate the area. On that side, I gave you the formula of calculating the area of different shapes. There is a square. The square we take a times a, which means side by side, and the answer should be in square meters. Actually, area, all your answers have to be in square meters. Look at the rectangle. We take width times height. Triangle, we take half of a base times height. Area of a parallelogram is base times height. On the diagram, I show you which one is the base, which one is a height. And on the circle, the area, we take pi. That symbol stands for pi, and it's on your calculator. And if you forget your calculator at home, or I don't know, the value of pi is 3.14 or 22/7. That's what we learn. So the area of a circle, you take pi times radius square. Radius is a distance from the center to a circumference. Okay. Then the area of a trapezium, we say half side A plus side B, and I show you which one is side A and which one is side B, and then you multiply by height. You need to know this formula by heart, because you will be asked to calculate the area in the examination. Then I gave you some examples. Calculate the area of the given diagrams. The area of a given diagram, for example, you are given a rectangle which is having 5 probably centimeters, and then here we have got 3 calculations. Then we say to calculate the area, we take width times height. Some people call it length. That's why I went back. Width times height. The area is 3 times, no, width 5. Okay, area is 5 times 3. Area is equals to, if it was centimeter, because of course in the exam there will be some units. Centimeter, our answer will be 15. 3 times 5 is 15 squared centimeter. This is very important because all the area have to be, the answer have to be square centimeter, square meters, square kilometers, square liters, and so on. It have to be in square measures. And I gave you a diagram in that presentation, in our presentation, of a triangle. Remember, triangle is half base times height. Half times base times height. Okay, and you are given the base, which is 20, and you are given the height, which is 12. And then the circle, remember the area of a circle is pi times radius square, pi r squared. So you take pi, I told you the value of pi is on your calculator, or you say 3.14, multiply by radius, the distance from the center to the circumference, it's given, the measurement is 3. Then you do the calculations. I also advise you that please take note, check some good examples of calculating volume and calculating mass in your study guide or in the grade 10 textbooks. You should also go through and know how to calculate volume and how to calculate mass in your study guide. We continue. We are busy with geometry. Study the diagram below. Here you are asked to find the angles. Many people struggle with this. I want to give a bit of attention here because people don't know the measurement of angles. Study the diagram below and find the sizes, the size of angle C, D, E, and F, and give reasons why you are saying, when you say F is equals to 130 degrees, what is the reason? You should do the calculations and you give the reasons. I will draw that diagram roughly here. It looks like this. Actually, that diagram have got a lot of lines and another one line. What are we learning here? We learn that this line and this line, they are parallel lines. And this one and this one, they are also parallel because of these arrows. So we are dealing with rules of parallel lines. We are only given 50 degrees here. This angle is given. Now they want us to find C, angle G, angle E, and angle F. When it comes to finding angles, very easy. You find the one that are easier to you. I will find C first. Why do I want to find C first? I'll find C first because I learned that in parallel lines, the angle here and the angle here are equal. They are called exterior angle. So my C will be 50 degrees, and you should look for the reason why are we saying that in your study guide. The other one, now I know this one is also 50 degrees. The other one that I can find is D. Let me take the green color. D. Why am I saying D is easy to find? Now that I know that this one, C, is 50 degrees, we have learned, or there are rules in your study guide to say the angles inside the Z, they are alternate. That is the reason. So therefore, angle D is also 50 degrees. And please, I'm giving you homework, look for that reason to understand why I'm saying the reason should be because they are alternate angles. Okay, now, how can, I will leave this one for now. I want to find F. F, they are angles on the straight line. This 50 and F, they are angles on these straight lines. Therefore, to find F, I take 180 degrees because angles on the straight line is equal to 180 minus the 50 that is standing there that we know. Our F will be equals to 130 degrees. That is the answer. I can write it in 130 degrees. Now I'm happy I can find E because of that rules that say the angle in the angles in the parallel lines, the angle that is outside is equals to the angle inside, which means our E, angle E, should also be equals to 130 degrees. Find the reason why we say so. It's in your book. Angles, one is inside the parallel lines, one is looks like it's outside. Why do we say they are equal? And this angle and this angle have to add up to a 180 degree because they are called co-exterior angle. Which ones? E and this 50 have to add up to 180 degrees is because of the rules that I explained in your books. Good. Then we continue. Now we understand. One of the topic is also bearings. Bearing is the measurement of direction. With north taken, north is very important. The direction of north is important and is taken. Why is it important? It's taken as a reference. The bearing measures, is always measured in degrees, and we always move clockwise. It's not like rotation where you rotate either to the clockwise or anti-clockwise. Here, with bearing, we always move clockwise. The way clockwise means the way the clock moves. You'll never find a clock that moves anti-clockwise. No, the clock always goes the same direction. So with the bearing, and on that diagram, there's also an arrow to show you that we always move starting from the north, going clockwise. The direction of measurement, you should always start from the north, going clockwise. The bearing is always written in 3 figures. If you have measured it and it says 90 degrees, it's written 090, 090. Why? Because there is the rule, mathematical rule that says bearings is always measured in the calculations, or the measurement should always be written in 3 figures. We continue. Bearings. The bearing is, okay, now let me draw a bit to help us here. Let me look at the new one. We say bearing always move from the north, very important. The north should be taken as a point of reference, okay, where the north is always there. You have learned in geography, for those who have done geography in some previous grades, north, south, west, and east. So we don't consider other directions. When it comes to bearings, we only worry with north. Why? Because we start measuring from the north always. Now they say the first point, the bearing east. The bearing on the east, if you move and you stop here, that means you have moved, is represented by 90 degrees. Remember our 90 degree sign. And then the bearing, we do the same for all angles. For example, if you want to stop here at the south, you move always from the north, you move from here to here, and you stop. When you stop there, we say that is 180 degrees. We are happy because these are already 3 figures, 3 units, 3 digits. We don't need to put a 0 at the beginning. But if it's 90, you put a 0 at the beginning so that bearings are represented by 3 figures. Okay, we are happy. If you are moving from the north and you stop at the line that runs south, you have moved for 180 degrees. Then we are saying if you move from the north and you want to go to the west, you stop at that line that runs to the west. I move like this, I come like this. I don't stop, I stopped to the line that runs to the west. In that one you have moved 270 degrees. How do we know? We know it's because each of these those lines are divided into four sections. This section is 90 degrees. Okay? This section is 90 degrees. Another 90 degrees here. It's moving well. 90 degrees here. Each section, each of those 4 sections is 90 degrees. This section is 90 degrees also. If you say 90 plus 90, yes, it will give us 180. We move for 180 degrees. 90 plus 90 plus 90, yes, it will give us 270 degrees. So my movement from the north stopping here, it covers this section and this section and this section, and all sections are represented by 90 degrees. And what about if I move from the north and come back all the way to the north again? What? I move from the north, I go all the way and I come back and stop where I started. That will be now full circle or full movement or full revolution, which is equals to 360 degrees. Why? Because this one is also having, this section is also 90 degrees. 90 plus 90 plus 90 plus 90, it's equals to 360 degrees. So whatever we are doing in mathematics is true and correct. We continue with bearing. Bearing north is represented by 0, 0, 0. Remember, bearing should always be represented by 3 digits. For example, you are given those ones. The bearing of point P, remember always starting from the north, is equals to 0, 60 degrees. The bearing of point Q, if you can see Q, it will give you 330 degrees. Okay, find the bearing of point B. Okay, if I have to find the bearing of point B, good. We have got some diagram, very interesting diagram in our presentation. You should always indicate the north. Why? That is our point of reference, and north is very important. They gave you to say this is point B and this is point A. Point A, the angle is 25 degrees, and point B from the north. Remember, we always move from the north to here, to that line, and we stop at the line. Is equals to 205 degrees. Which one do they want us to find when they say find angle B? Angle B is this one inside. But now, to get that one, because we always move from the north up to here, we have to use 360 degrees. 360 degrees minus what is given. This distance is given. We always start from the north. This distance is already given, that it's 205 degrees. The remainder, we are looking for angle B. The remainder, angle B, is equals to 55 degrees. 55 degrees. Therefore, because we are dealing with bearings, angle B is equals to 0.55 degrees. Many people always forget to write the 0 at the beginning. When I say you gave me the bearings and you only gave it as 2 digits, 2 numbers, it's wrong. You are losing marks because you are not following the rules of mathematics. So, yes, your calculations, you get 55, but because we are dealing with bearings, you should write your final answer as 0.55 degrees. Most of from my experience of marking your scripts, people forget that bearing should always be given as 3 digits. We continue. We have covered our geometry topic, and that makes me very happy because there are many people, there are many students not really crying, but they feel so sad, they don't understand geometry. And here we have just covered the topic of geometry. What should I say now? This is the end of our presentation. I wish you, or we at IOL are wishing you all the best in your upcoming examinations. I think most of you have started with other modules already, and you still have got more modules. Yes, you have studied very hard. You have been studying very hard. Students don't sleep during the examinations. I wish you all the best with all the remaining modules, more specifically for mathematics, numeracy and mathematics, and of course research. All the best.